Uh, Welcome to this video. This is Said Ahmed from Toronto, Canada. So, in this series, we're actually seeing how to implement a research paper step by step. It's about stock prediction using deep learning, machine learning, and graph theory, right? So, we had a couple of other videos, 4 or 5, I believe 4 videos, and there is one another. One another I created, but I did not upload it. And that is one thing, and also the video recording or the code, it didn't work very well. So yeah, it is about I just trying to create the large data set, right? I try to create a large data set. I try to use it into the code. So as far as I remember, something went wrong. Anyway, let me upload it first, and then I'll show more on the model side. So this is the channel. Now I just want to upload it, right? So I'm just uploading in the back. Okay, I'm not certain that you can see the everything. I hope you can. I believe the file explorer that did not get shown. I believe create the large data set for stock market prediction using ensemble of graph theory machine learn. Okay, I think it just the file name is too long. Okay, so the corresponding graph mining. Okay, ongoing and everything. So these are the class list, playlist, not class list. Okay, I need to move the okay, step 5. Now let's go to the project itself. Let me open it in the back. I'm just going to the uh, Anaconda Navigator. So Anaconda Navigator, I right click and run as administrator so that I have permissions all around. So I did not share the screen, so you cannot see it. Let's share the screen. Anaconda Navigator still it's not in the place where I can share it. So I better wait. Sorry. So Anaconda Navigator, you can see it. So I'll be using Stellar Graph. It is graph mining library. Actually, They also make use of the basic TensorFlow, Keras, or some other libraries to create these methods as well. Okay. So Stellar Graph, the thing is I created another virtual environment because it requires Python version less than 3.8. Okay, less than 3.8 or less than 3.9.0. So my default one has a higher version, so keep that in mind. Okay. So I just went to the Anaconda Navigator and command prompt. Okay, I don't believe that you can see the command prompt, but I'll just go to a particular directory and then Jupyter Notebook. Okay. So when the Jupyter Notebook comes, okay, I don't believe that you will see the Jupyter Notebook. You are seeing the Anaconda Navigator, Jupyter Notebook that will come through the Google Chrome. Okay. So let me share the Google Chrome. Okay. So you can see the code, right? Now, because if you watch our previous videos, you are definitely familiar with the code and our approach, right? So let's see where I am. Yeah, stock market, and I'm prediction the stock prices, and then I get some output. I'm just trying to see if I got the sensible output or the output that is not really that uh, sensible. No, it's not, the output is not a good state. Good state. Anyway, I believe you are familiar with the other graphs. I think this is not the thing. We have used other models. I think I got different graphs and less errors, but still I'm not saying that the prediction part is done and the code is giving us good output. There are some caveats, or it definitely needs to be worked on. I'm not even saying that it's in the correct state, but we will go there eventually. So let's say I will be using this model and experiment with models. I'm just keep it for now. Let's mark it as a comment. Okay. So the model that I will be using is this one, right? So what I am doing it here. If I want to show what exactly I am doing it here, let me say, as I told, I'm implementing a paper, right? I'm implementing a paper. So I can show that what exactly I'm trying to do. Let's see, it is stock market prediction. So this is the paper. I don't think they have given much. Let's go youtube.com. I have some stuff over there, so I can just show you. I'm trying to show you the model in the original paper, right? I need to go to my SaLearning School and Sites tree. I hope it finds it. So I believe this will be the one, right? And if I go to the videos, so okay, I can show you the model somewhere. Okay, this is the model that the paper is using, right? So this adjacency matrix and this feature matrix. Feature matrix is the time series. Adjacency matrix is the graph structure. I think depending on the relations among among stocks, we create this graph. We already did it, right? We have the feature matrix. We have this adjacency matrix, and we also have this graph convolutional network, and we also have this convolutional neural network, right? We have it, and we are passing it. But here they are using multiple blocks, right? One block is one. Okay, let's say it may or may not be one convolutional layer. It can be multiple, but I think the specific thing the paper did not say it, so I cannot say it, but I can say at least graph convolutional and then CNN. That is one block. Another graph convolutional CNN, right? And then the MLP and the Y. So in my model, what is there? One graph convolutional layer and one CNN. It is there. Now, in my case, I'm using many different graph convolutional layer, many layers of GCN, right? GCN and one dimensional CNN, that is there. Now, in their paper, whether they used one GCN and one CNN, then one GCN, one CNN, that I don't know. One layer of GCN and one layer of CNN, and then one layer of GCN and one layer of CNN. I think the paper is not clear on that, and there is no implementation. So far, I did not find it. So I'm not quite sure, right? In my case, I used multiple layers of GCN and one layer of CNN. And then I also have the MLP and then the predicted. And so far, it gives good prediction. But another thing is, let's say, okay, good prediction. If I think about MSC or loss in those things, it looks it's keeping good. But if I say the exact predicted price, it seems okay. But another thing is, there are a couple more things that I need to get clarifications. Apparently, it looks like it is estimating price for each of the next time steps. Anyway, the thing is, the prediction is there. Loss is not much, or mean square error is not much. Those are the good parts. But in terms of the models, as I told, I have some part, but not everything is matching. So I need to see what to do there. Okay, I think before showing you the code, I'm talking too much. I hope, let me see. So in that case, what my GCN is doing, right? Sometimes if I talk and try to explain, I probably get some more ideas, right? So that probably one another reason sometimes to create a video and explain it. Okay, so let's see layer sizes and activations. Okay, 32 layers of GCN, 32 layers of GCN. I think you can just try 32 and ReLU, that will also work. This is the GCN graph. And this generator is coming from the graph data, right? The graph that we created. Okay, so this graph, I think it's a this Pycharm graph. We form that structure, that information into stellar graph, created a stellar graph using those structure, and then that stellar graph, there are some API or library in the stellar graph, full batch generator, or there are some spark generators. So I use the full generator and that graph. So that graph generator, that is the generator to be used in the in the GCN. Okay, that is that generated. It is coming from the graph. And the graph, this data also has that node information, time series, and all those things. Because the stellar graph that is both edge feature and node features, and the structure, everything is there, right? Now for this, we're just trying to say for this GCN, what is the input and what is the output? Input tensor, output tensor. Okay, so input tensor, output tensor, and this is the prediction. This is the uh, activation, the multi-layer perceptivity. It is there. Okay, I believe I probably was able to make some of these two working. I'm not really sure if I did not save it or there is one another file. Okay, so let me see what is the experiment. Okay, that probably was in the experimental model. In the experimental model, I could make the convolutional CNN layer and GCN layer working together, just one block, not multiple blocks. However, the prediction did not seem right. This one, it seems predictions to be okay. It seemed to be okay. Okay, so GCN and the multi-layer perceptron, right? It seemed to be okay. Okay, let's go there. Other than, okay, if I make it code, so I just use 16 GCN layers and then using ReLU. And then, yes, I think I could also use the dropout. It doesn't hard to use. So this is the input and output sensor of the GCN graph. And this X out, this is the CNN layer. Okay. And this is the GCN layer 2. Okay. But okay, I'm not using X out, so I cannot say that the chain is get created, the multiple step. No, it didn't get created yet. So it is not just to GCN2, it is not being working. Okay. Okay, and then this model. So this model, okay, it is using the input for that particular, the generator or those. The output is the predictions, that is the output. And I will need to fit it, right? So early stopping, I think if model does not improve, the result doesn't improve, I think after 50 iterations, if things don't work well, we will terminate early stop. That's what it is for, right? So it is pretty much common that I think that this is the common structure that we use. At this moment, I am using Epoch 10. I think what I noticed that when I used Epoch 2000 or 20,000, Epoch 20,000, that I started to get good result when I first used 20,000. But if I take a look at the graph, but sometimes it looks we probably don't need the 20,000. Probably when it worked was for 20,000, probably some other parameters were not good then. Anyway, after model fitting and then it is running and then it will be plotting this. Okay, let's not 10, let's make it 100 so that we can. Okay, let's 100. I think it is the second model that will be working now. That is the convolutional neural network, GCN, CNN, right? Okay. So X out and the predictions is using this X out. So it is taking into account this convolutional. neural network, CNN, right? Okay, first clear all. And then restart and run all. Okay, I hope it doesn't take much time, but the epoch and iteration thing, that will take some time for sure. Okay, it is done. So let's see. Okay, not here. Okay, compile, test subject, string generator. Okay, here, right? Okay, keep it this way. This is the loss. So after around sometimes training loss and the validation loss becomes equivalent to training loss. So okay, loss is not much anyway. But the thing is predicted prices. Okay, it looks like I think the convolutional layer, it probably is not doing a good job. That probably also does not look to be a good CNN layer. That needs to be fixed. Actually, I need to check through the CNN and then work on it. Let's try the other model. What predictions do we get? Okay, I'm getting output up, but it does not mean that this is correct thing. There are several caveats and it doesn't match with the paper. So uh, I think still I need to start from somewhere and then uh, step by step make it better, right? I need to read the paper again and again, understand what they mean, and then uh, fix things. So let's mark down. This is the X. Okay. So I have given 100 iterations. So let's see it. At this point, I will be using this, just the GCN and the MLP layer. There is no convolutional 1D layer. So kernel, restart and clear output. Okay. Okay, now it's got done. Okay, it's working. Okay, while it work, let's say that this one I just used GCN and MLP. GCN has multiple layers, right? So, and GCN and the MLP, that's how it is work, right? And when I was doing the other one, that didn't give us good prediction. Let's say GCN, CNN, and then MLP. One of the challenge I found using another block of GCN and CNN. That is one uh, one challenge. And the CNN layers, it probably is not uh, doing a great job, right? So, okay. Now, some other possible variations with this model is, and also the thing is, the paper did not mention exactly. I think because it's a research paper, right? Research paper, they are not supposed to give you all the details all the time. So anyway, so there could be one another thing. I could feed the graph. I could feed the graph to the GCN, and I could feed the time series to the CNN. Ideally, as per the paper, CNN works with the time series and GCN works with the graph. So there is no need that I pass everything to the GCN, right? Now, there is no harm because the GCN is taking the graph as part of the node. I am supplying the time series. That's okay. Or if not, I can take it out, but in that case, whether GCN will work with this or not, that probably will be another thing to notice. Let's say, so in that case, what I can do, time series pass to the CNN and graph time pass to the GCN, and whatever I find from the GCN or whatever I find from the CNN, and do some operations on them. And whatever I get out of that, and then I pass the corresponding graph to another GCN, and the output of the CNN, I think output of the GCN passing through CNN. Okay, no, I think the paper how did it show, pass the time series to CNN and then pass the uh, graph to the GCN, right? Pass the graph to the GCN and output, and they do something within these outputs, right? Within these outputs, and then they send again graph to the GCN and time series to the CNN. Now the modified time series and modified graph. Now then the question becomes, what did they do between this uh, first layer output of GCN and first layer output of CNN? They did some operation as per the paper. So that is something I need to find out. Okay. Now it can happen that when we initially created the graph, we fed the time series as part of the node feature. So probably after CNN, whatever time series that comes out, that node feature, we again can insert into this graph, output of the GCN layer graph, and then send it to the next level. Now, the GCN, those are tensors, right? So we need to see what those operations can be, and then we can send it. So that is there. So that can be one approach. But another approach, you can see that there are some 1 unit of GCN or 1 unit of CNN, right? 1 unit of GCN or 1 unit of CNN, rather than using a stellar graph, you probably can create your own library or own code that using Keras or TensorFlow, 1 layer of GCN and 1 layer of CNN, and another wrap up class that will be uh, creating this 1 layer GCN, 1 layer CNN together as a block. And then your code can call multiple such concatenate multiple such things to create the total architecture for this graph, and then predict the price. Okay, so there are multiple ways of doing it, but which one the paper has made and which one will work, that is still a question. Okay, now say this is the, let me see, how do we see? I think at this moment, it is there's the GCN and the MLP. Okay, I think if I take more epoch, you will see that this becomes smooth. So it's comparatively low. I think if I use more iterations, more epochs, it will be way lower. Okay, it still looks that okay, the output actually does not look good. However, it looks like it used to look good. It reflected. Okay, in that case, let's see. When the output looked good, I believe I used around 20,000 epochs. Then this output actually reflected this. I think this is also the input stock prices. So yeah, I think it was more closer, right? Now we still have some mini square error is high. If we use 20,000 iterations epochs, then uh, it becomes slower. In that case, graphs become smoother and the price also comes comparatively uh, better. Let me see if I can show any such. Okay, I'm checking. No, I did not keep a screenshot of 20,000. Okay, let's review the code one more time, then I will stop this video. And at this moment, I want to focus on the improving the model. So that probably I need to work on a bit. So importing libraries, drop rows with, okay, my input data has lots of zeros, right? Lots of null values or missing values. So that's probably one thing. So whether I want to drop it or not, that's probably one thing. So yeah, in general, stock market price, it is not supposed to be zero. In general, I think the data probably just missing, right? Okay. I'm converting the date as a date time so that I can sort the dataset data. I can sort the dataset data. Okay, so that it makes sense because I saw that otherwise the data is arbitrary, right? Data is arbitrary. You can see 2003 March 1 and then 2020, 2022, or then again 2012. So that is not the right way, right? Because stock market price, the data set needs to continuously increasing, right? So pivoting, I think just making the column name to be the stock tickers. That's what it is. I think we want to change it and the date comes here. It goes there. Yeah, ticker and date. That's was our goal. If we want to replace, then we'll be replacing. Replacing all the rows, not the values. Yeah, dataset needs to improve, right? So correlations, and depending on the correlations, we create those graphs if threshold is a greater than particular things, right? Network X, I use network X to for this one. This is where I'm trying to create the stellar graph, right? Stellar graph with node features. As part of the node, I will be supplying the pricing data. So node data. So this is what it looks like. Okay, so we're creating the stellar graph and using the generator. We are using the stellar graph for this generator. This generator, we pass it through the GCN. GCN needs this type of generator. Okay, it is using GCN and local pooling internally, right? So it's a deep neural network, and then we are dividing the train and test. I think we are using okay, I got a message. I'm just checking what is this message about. Okay, so then and then the model that I already told. So this is just a model summary. Let's I can do 1000. Okay, I'll execute and terminate this video. It's running. So you can see validation matches with training, loss, predicted price. Okay, are these